Guys can see me? All right, hi, welcome to the session, to this morning session, Saturday the 1st of May from the lovely Durban, but we are really feeling cold here today. The winter has started. We are presenting from the Durban University of Technology, and as you can see, the lab behind me, we have a lot of equipment. This is our IoT lab, our robotics lab. I will show you all the items as we go along with the presentation. All right, so I'm going to do an introduction first. So you guys have seen me. Imtiaz, I just want to say hello before I pick up the presentation. Hi.
Hi, guys.
We are the two presenters. My name is Ibrahim Asmal. This is Imtiaz Hanif, and we'll be doing the session for you guys today.
Okay.
All right, let me just share my screen. All right, so the presenters, as I said, are myself. I'm a senior lecturer in the Department of Information Technology and the department, at the Durban University of Technology. And we have Imtiaz Hanif, who you met just now. He's an electronical engineer, also at the Durban University of Technology, based at the Department of Electronic Engineering. We're in two separate campuses, basically. All right, so I'm going to do the first part of the presentation, the session one. Imtiaz is going to do the second part of the presentation, which is session two. So the program for today, session one, I'm going to go over some background and go over coding and robotics, and why, importantly, why do we need coding and robotics? What is the purpose of coding and robotics? Why are we introducing it into our schools, etc.? Session two is going to be a practical demonstration. It's going to get how we're going to put everything together. So you guys have done a week of coding, I assume, right? So I know the last week you guys have done some Scratch, you guys have done some Python. Now, how are we going to take those programs that you have written and place them onto robots, onto devices, in order to function in a particular manner? So Imtiaz is going to create an entire practical demonstration for you. And session three, we're going to leave for any Q&A, so question and answers that you might have. So I'll just go a little bit of background. I want to start with what is IoT, what is VR, what is robotics, what is coding. This is all part of what we call 4IR, the fourth industrial revolution. You might have heard of this. We should be in the middle of the fourth industrial revolution right now. All these technologies that we are talking about, robotics, artificial intelligence, virtual reality, machine learning, robotics, deep learning, 5G are all part of the fourth industrial revolution. I'm not going to go into too much of detail into all this. We'll do that at some later stage. Okay, so I'll put up on the screen, a slide on the screen, there's 2030. This is the year which they say we're going to see the largest amount or the hugest impact of the fourth industrial revolution. But really, I think that year is going to come down quite a bit because COVID has forced us into a lot of things that we have now changed. And we thought we will do it somewhere along the line, but because of COVID, we were forced to make that change much, much quicker. So that year might come down quite a bit. That is what I think, by the way. Okay. So going back a bit, we had firstly the first industrial revolution, which was basically steam power. It changed a lot of things. Okay, I'll come to that just now. We had the second industrial revolution, where we went into mass production. Third industrial revolution was computers, digital, automation, a little bit of electronics that came into play. And now we are talking about the fourth industrial revolution, where we're talking about the Internet of Things, network, where there is now isn't a clear distinction between physical and virtual anymore. They are now combining and become like kind of one. But that's a completely different lecture. We'll go that later stage. So what is consistent with all these things that have happened? The first industrial revolution, the second, the third, and the fourth, okay, is basically impacting on the way we live. The way we play has changed. The way we live has changed. The way we do business has changed. And it's only because of one reason, technology. So if I had to define 4IR to you guys, what would I say? 4IR definition is an extensive or massive use of technology in our daily life. From the time you get up till you get up the next morning, we are using technology. Right? So what has happened? Okay, we've got large-scale automation. We are now connecting billions and billions of things onto our network. Okay, we are increasing our skill levels. We are working smart. With automation, what's going to happen? We're going to have millions and millions of job losses. People are going to lose their jobs. Why? Because you're going to find different ways of doing things. But all is not lost. Okay, also that for you just now. Okay, just going to play a little video for you guys. Okay, this is a robot. Okay, about 3 years ago, I was sitting in China in a hotel called Tianjin, right, or in a city called Tianjin, in the lobby waiting for somebody to pick me up, and this is what I see: a robot. What is the purpose of this robot? Simply stated, if you make a call downstairs to the hotel reception and ask or order something like a toothbrush or food, it will be delivered to you by that particular device out there. And it communicates with the lift, it communicates with your doorbell, it hands the item to you and comes all the way back down into its cage. We're going to call it its home. Okay? And this was 3 years ago. And you can see the level of automation. Okay? We're removing the human contact. And we said that there will be waves and waves of job losses, millions and millions of jobs will be lost. Okay? But look at that. We're going to need people to manufacture that, program it, design it, make sure it works. Look at the front of it. There's a drawing of a face out there, I see. We need artists as well. Right? So there's going to be millions and millions of new jobs that are going to be created as well as we move along. So all is not lost. So what else is going to happen? The rich are going to get richer, the poorer are going to get poorer. The digital divide that is around is going to increase. Okay? And we need to ensure that by implementing things like the coding and robotics programs that we have, we try to narrow that gap. Okay? Remember, the real issue is not in the cities, in the urban areas. The real issues are in rural and deep rural areas. We got to find some way of taking coding, taking robotics, taking 4IR technology into the deep rural areas. We also have ethical issues. Okay? Are we playing God? That is the question we have to ask ourselves. Because we now can go right down to your DNA level. We can create humans. So what have we done to address the situation that we're talking about? South Africa, firstly, has developed a policy document by the Department of Basic Education. Okay? What does it say? Okay? It's coding and robotics from grade R to grade 9. And here I would like to basically give a standing ovation to the South African government and the education department, because we are the first country in the world to have a policy document for coding and robotics for schools. Okay? So we will become the market leaders basically, if we do it the right way. So what does this entail? So here I'm referring to the policy document. Remember, this has been released for public comment already, and I think that closed on the 17th of April, if I'm not mistaken. So what is the focus content areas? Okay, remember, this is going to be done right from grade R, the first year that child goes to school, right until the time the child is going to leave school. So every year, okay, there is coding and robotics as part of the syllabus. And it has 5 strands. And these 5 strands are also going to be done every year. The 5 strands being pattern recognition and problem solving, algorithms and coding, robotic skills, that's what we're planning on doing today with you guys, internet and e-communication skills, and application skills. So every learner will be coming out with these skills and starting at a very, very young age. So why do we want to do this? Firstly, by implementing coding and robotics in school level is going to improve your skills in all your other subjects. Mathematics, your sciences, English, art, okay? That's one of the most important things that's going to happen. Why? Because we got a new skill set that's going to be required for the 4th Industrial Revolution. We need to change the way we do things. We need to learn new technology, otherwise we're going to be left behind. Otherwise, we are not going to be prepared for the new skill set that's going to be required in the workplace. And you will notice that as you look through, the entire syllabus is geared towards electronic engineering, mechanical engineering, mechatronics, information technology, and computer science. So they are preparing you for a career. It's basically, I'm not saying there are other things that you can't do, but these are the main areas that they are preparing you for, right? Because again, remember I told you, millions and millions of jobs going to be lost. Also, millions and millions of new jobs will be created. But these new jobs are going to require a complete new skill set. And coding and robotics in school starting at such an early age is going to give us this new skill set for these new jobs that are going to be out there. What is coding and robotics made up of? So I'm now going into detail, and some of these things you have already done within the last week, all right? So for coding and robotics, we need two things. We need hardware, we need software. Those are two things that we need, okay? On the software side, yeah. Now remember, I'm just talking of there's millions and millions or thousands and thousands of different programs out there that you could use, okay? So we are just discussing the popular ones out here. Firstly, you must have an operating system. For any device to work, it must have the operating system, the system software. Okay, the most popular one that we use on our Raspberry Pis that we have is called Raspbian. Okay, and then we need application software, programs to run, and the programs will be developed in a language. The two most popular languages right now are Scratch and Python. And during the week, I think the lower grades did Scratch, and the upper grades, I think 7. Oops, sorry, that's my robot. Upper grade did Python. All right. So this is the software that we require. Now the software has to work with the hardware. So it has to be implemented on the hardware for it to function in a particular manner. Okay. So while we at it, this is a robot. Okay. This is a robot. You all can see that. This robot we've named Natasha, by the way. We won't say why. So that's the software. So now we're going to go into the hardware. What is the hardware? On the hardware side, there are three main categories or areas that we need to consider. Firstly, we need a microcontroller, we need actuators, and we need sensors. So the software with the actuator, the microcontroller, and sensor will create an item or a project for us to basically develop and use. So, on the hardware side, on the microcontrollers, the most popular microcontroller we will use or we have is the Raspberry Pi. Yeah, you get the Pi 2, the Pi 3, and now we have the Pi 4 that is out. Pi 4, I think 3B plus. There are different models. Okay, the main differences between them is the speed, and I think Pi 4 has Wi-Fi capabilities incorporated into it. Also, some of them you find them with 2 gig of ROM and 3 gig of ROM. The popular one you should buy, I think, it's just the 4 gig. Sorry, the 8 gigs on the Raspberry Pi. All right. The pricings are different, depends where you buy from. The other popular microcontroller that we use is called the Arduino. Okay. A lot of projects you'll find we connect the Arduino to a Raspberry Pi in our project, depending on what the project entails and what is required from the project itself. All right. So the differences between them, one is digital, which is Arduino, and one is more analog, which is the Raspberry Pi. So if you want both analog and sorry, the other way around. Raspberry Pi is the digital and Arduino is the analog. So if you get analog signals, you're going to use the Arduino. If you get digital signals, you're going to use the Raspberry Pi. If you get both analog and if your project needs both digital and analog signals, you can connect a Raspberry Pi to an Arduino as well. So those are the two popular microcontrollers. That does not mean there aren't other microcontrollers out there. Just that these are the popular ones that are being used by industry. Actuators, okay, like a water pump is an actuator. There are samples of your actuators out there. Actuator is a device that's going to do something, like a lock on a door. It's either going to open or it's going to close. It's going to move the arm left or it's going to move the arm right. It's a device that we use. And you have thousands of different actuators out there. Again, depends on the project that you are trying to accomplish. Then we have the sensors. Okay, so these are all the different types of sensors that you have. We have water flow sensors, heat sensors, humidity sensors, temperature sensors. There are thousands and thousands of different sensors out there. And we need to make all these things work together. Right? So that is where I go to the next slide. Right? Putting it all together. So what will happen? Okay, so I'm going to use a common practical example out here to try to explain this to you. All of us that in motor vehicles, and all our latest motor vehicles, you would find that none of us put on the wipers or put off the wipers. It comes on and it goes off automatically if it rains or not. So the wiper is off. We have sensors placed on the windscreen. Okay, like this here, I'm just going to show you here. This is a sensor. Obviously not that one, but a sensor like that will be placed on the windscreen. Okay, and that sensor is picking up or testing the humidity level, how much of rain is falling onto that particular device. It's sending the results of that to the microcontroller, which is either a Raspberry Pi or an Arduino, for an example. Right? The center part of this part here, that's your microcontroller. So the signal is coming from there to the microcontroller. On the microcontroller, you've got your software running that you wrote in Scratch or you wrote in Python or any other language running out there. And it's analyzing the data that is coming to it. The signal from the sensor to the microcontroller. When it determines that the humidity level has increased above a certain extent, what will it do? The microcontroller then, this part here, sends a message to the actuator. What is the actuator? The motor that controls the arm for your wiper blade. What does it tell it? Come on. And you see the motor starts up and your wiper blade starts moving from left to right, right to left, clearing your windscreen. That sensor is continuously monitoring the humidity level at that particular point on your windscreen. If it starts raining heavy, it's going to send a message again to the controller. Controller, they are increased again. It's going to send a message to the actuator, which is your motor, to start working faster. Or the other way around, the sensor picks up that it has stopped raining. The humidity level has dropped. It sends a signal to the microcontroller. The microcontroller analyzes that data by the software that you have written, determines it has fallen below a certain level, sends a message to the actuator to stop working. Okay? Basically, in a nutshell, that is how it works. I'm not going to go too much into detail of this because this is Imtiaz is going to show you at a later stage with the practical example. Okay? So where would we buy these things? Yeah, we can get them as individual items, like you can buy a Raspberry Pi, you can buy sensors, you can buy actuators and build your own little project. Okay? Then we also have kits. Okay, kits like sorry, in that box, can you just give me the kits from there as well, please? Like Lego. Okay, you can buy a Lego kit. It has all the items in it to be able to develop, excuse me, a robot, for example, in this case, or a autonomous motor vehicle, a car. The other one in the ground. I forgot about that. Okay. So there are many, many companies out there that sell what we call kits. The other one that we have, and this is a South African company, okay, are the Resolute Kits. This is a company in Johannesburg. Okay, they have them for different ages. This is a beginner kit, okay, and this is more an advanced kit. Okay, but these are especially as the items, like for example, this here is a cobot kit or robotics kit that teaches you how to build a vehicle that can follow from one point to another. This particular kit has an automatic dispensing system that it creates. That's the one that you are seeing on the screen. Right? So you have an option. You can either buy a kit or you can buy individual items. At the universities, we buy individual items. And we build as we feel fit. So we're going to build robots. So what does it mean? Bill Gates has suggested that the robot that takes away your job should pay taxes. Okay? How far that is really true, where it's going to go, who knows? It could be a possibility in a few years. Because if you look at Standard Bank in Johannesburg, all their back-end systems, they are no humans. They are being run by robots. And robots can take different shapes and sizes. I'm going to show you a few just now. Okay? So I'm just going to play you a video next. All right. Stop sharing. Okay, you guys can still see me? Okay. It's not a stop video, am I right? Oh, yeah, I can see me. Why is it logged? Logged on, are you presenting? Are you seeing my one? All right. Now we are in our lab. Okay. You will notice that I've changed my clothes very, very quickly. Okay. I'm now wearing what I call a haptic Tesla bodysuit. You all can see it. Sorry, I didn't take off my t-shirt. You can see a little bit of white sticking out. Okay. This bodysuit costs 400,000 rand. Firstly, it's the most expensive suit that I've ever bought or ever going to wear. Obviously, I won't buy it myself. The university has bought it. So what does it do? It is now monitoring every part of my body, from my heart rate to my muscles. And it's totally haptic. That means we are now going from the real world to the virtual world. From going from the real world to the virtual world, you're going to need immersive technology, like the bodysuit that I'm wearing. Haptic means it has transmission in both directions. That means it's recording everything that's happening by me onto a laptop out here. So my heart rate, my pressure, etc. Also monitoring my muscles. Also monitoring my every movement is being replicated on that particular device. That device now, okay, my PC with the recording can now be placed onto robots like these. And these robots can now will be able to mimic exactly my movement as I have been presenting out here. So you notice that these are technologies that we are moving towards. And remember, I said immersive. Okay, that means that device out there can also send me a message. For an example, I might be playing a game, a racing game, like tomorrow is the Grand Prix, the Portuguese Grand Prix, and I might be playing the Portuguese Grand Prix game. And guess what? If I meet with an accident, I will actually feel the accident. Okay, remember we said it is haptic, both ways. All right. Then you will find other devices out here. We have drones. This is a power egg. Okay, this is a DJI drone. Now, this is a drone that can fly for about 30 minutes, 45 minutes. What we have done is that we have now taken what you have seen in the project out there earlier when I showed you. We've taken a Raspberry Pi, a microcontroller. We've taken an actuator. We've taken sensors, and we've placed them onto this particular drone, so that we can fly it to be able to pick up data from the atmosphere, environmental conditions, to determine whether a particular area is safe for humans or not. For an example, Okay? We've had a huge explosion at the engine refinery in a place called Meerwyn. It's about 20 kilometers, about 10, 15, 20 kilometers away from here. Okay? And there are a whole lot of people that live around the residential area. And there was this thick black cloud of smoke that was emanating from this refinery. Now, it was not safe to basically send humans in there. So what did we do? We sent in drones. We sent in robots to be able to determine the quality of the environment, whether it was safe for humans to enter or it was not safe for humans to enter. How did we do that? The sensors gave us all the readings in real time. An example, the sulfur level, the humidity, the temperature. And all these things were then sent down to the cloud and analyzed so that informed decisions could be made. We did not send in the fire services at a particular point in time because they would have died because of the amount of sulfur in the atmosphere. Excuse me. Okay. So we use devices like this. So, and we take them and we adapt them to be able to be used in specific situations. For example, the police services. Before they can get to a particular point, they could send in drones to determine whether it's safe and how many people they need to send in to be able to address the situation. Or for an example, they found a parcel lying in the building which they suspect it's a bomb. Why send in a human and place a human life at stake? What will we do? We will send something like a robot in there to be programmed and to go all the way to that particular device and determine whether first it was a bomb or not, and if it is, how are you going to rectify the situation? We also have COVID. COVID has changed a lot of things. One of the things that we need to be careful of is, do we send humans in particular situations without knowing exactly what the situation is? So we use robots, we use drones, okay, that we send into these dangerous, what I would call dangerous situations, so that it makes it easier by gathering all the data to make informed decisions. The informed decision could be, please don't send anybody in, they would die. Or it's safe to go in, now you can go in, not a problem. So these are the things that could happen. The other devices that we use, I'm going to show you quickly. On the drones itself, these are what we call headsets. Okay, so you can actually see where the drone is flying and control it using basically the bodysuit to feel what is going on and actually feel the total experience of the drone itself, as if you are actually there. Remember, we spoke about immersive technology. The other kits that we use, which are very popular, okay, are the Sunfounder kits. Okay. You can buy all these online, by the way, off the net. These come with things like the breadboard, the Raspberry Pi, sensors, actuators, etc. There's a little project that is built up here just to switch on and switch off lights. So we have, this is what we call white stuff here. Imtiaz will go over just now. It's called the breadboard. And remember, you'll notice that we connect wires and we can remove those wires. We don't solder them because we can reuse our projects. If you solder the items on, you won't be able to use it again, okay, or reuse it. Okay? So we use what we call breadboard. Okay, this is whiteboard here, so we can put in and take out basically our wires as and when required. We have tons and tons of sensors. And for play, we have things like what we call a spider. This is a robotic spider. Make a spider. Okay? We can also program this and send it into dangerous situations to be able to determine, again, with sensors out here, whether it's safe for humans to enter or not, or send us feedback of what is going on in that particular area. Anything else that I need to know? That should be fine, I think. All right. So, I hope you enjoyed the session. Okay, I'm going to now hand you over to Imtiaz, who's going to take over the practical demonstration for you guys. So he will proceed, set up his presentation for you guys, and I'm going to hand over to Imtiaz. Imtiaz, all over to you. I think I'm going to just stop sharing for a second, guys. I stopped sharing already. You can start sharing. Yeah, I need to open the folder. Sorry, guys. Desktop. Which one? This one. Okay. So, share. I need to share. Share. There we go.
Welcome people. Mr. Ibrahim has given a very good introduction to everybody, and I was listening to you very closely. I hope you guys are also listening to me very closely as well. And what he said was, which actually made me think. I've just added this part of it now, where I heard him talking about the Industrial Revolution. Very interesting point about the Industrial Revolution. Number 1, 2, 3, and also he went to the 4th Industrial Revolution. You may be frightened about this here, where people are losing their jobs. This is what he highlighted. But you must also remember that for every job that we have lost, okay, when I say job loss, I don't mean people losing their jobs. I mean, there's a particular type of job. For example, if you look at the banks, where the teller now is going to be replaced by a robot. I'm talking about that type of jobs. Now, if you look at those jobs there, for every job that was lost, it has, because of the new industrial revolution that's coming up, there's about 20 or 30 other jobs which are being created. So there are more jobs created, okay, for maybe one job has been lost. Now, when these jobs are created, there's a requirement for these jobs in order for you to fill the space. And we need people to actually go into this field, okay? And this is how we find that the new generation will have to be brought on board and trained so that they can also contribute to a country and also to the 4th Industrial Revolution. Remember, 4th Industrial Revolution, a major component of this is human beings, not robots, a human being. If there's no human beings, there's no robot. If there's no robot, there is no 4th Industrial Revolution. Very important point to understand. That's number one. The second important thing to understand is that these robots are only machines, and they have no intelligence at all. The intelligence of these robots come in by human beings. Whatever you have within yourself and how you think, okay, how you observe, whatever you see around you is what you have to program into this robot to put life into it, as such life. Like Mr. Ibrahim was saying just now, you talk about life, whether it be God or what? No, we are not God. We can never replace this. Okay, you must understand one thing. If you look at the human being, okay, look at your eye itself. You can never ever replace a human eye with a robotic eye. You can never do this. There are millions and millions of nerves that goes into your eye, which the robot, it'll take you many, many years just to replace your eye. Okay, that's where they're coming from. Now, as Mr. Ibrahim has said, I come from an electronic background. Okay, and when I was studying, just for information for you guys, when I was studying, my entire study of 4 years at the university to become an engineer, I never saw a computer. I never saw a computer. Okay, when I started work, the first time I saw a computer. So you see, in order for me to stay in my field, I had to self-study and learn programming and learn microcontrollers while we're doing this. I actually felt the new revolution coming in which I studied this old. Now I have to come up and from it, before it was not so much electronic engineering, it was electrical engineering. And then from electrical engineering became electronic engineering. From electronic engineering, now what do we have? We have a thing called mechatronics engineering, which is a mixture of electronic engineering and mechanical engineering. Okay, so we have that. There's many other engineering fields that are opening up now into this. There's control engineering. All this. What I'm going to do now is that I'm going to go show you how we're going to go into this robot that you see here. It's a very pretty picture. But there are components in this robot. Okay, the smallest component you can go to that actually makes up this robot to what you see right now. Okay. So what we're saying is, if we're gonna, it's coding and robotics, we're putting it all together. That's what we're saying. So when you go to school, okay, from grade R coming up, okay, we learn coding. The coding that we learned was Scratch, and then as you became, you came into grade 8 up to grade 12. Grade 8, 7, 8, and 9 is Python. From 7, 8, and 9 is Python. Okay, so you basically went that route with the coding side. And then also, while you were learning coding, they also taught you other skills, which is basically linked to mechanical engineering and also electronic engineering. What did they teach you there? They taught you about linkages, they taught you about pulleys. Okay, those are mechanical links. From electronic side, they taught you LEDs, wires, some servo motors. They taught you all this. When you take these two fields of coding, okay, you may think coding is only software. Okay, and then you got the linkages and LEDs, you may think that's only hardware. If we take the both together and marry them, we come up with a system called an embedded system. That embedded system is the foundation of, you see these 3 blocks here of the robot. All of them are robots. There's a car, then you find there's a robot here, and then there's a robotic arm. Okay, so we've got these 3 opposites. In fact, it's not limited to 3. This output of here you see are many and wide. Okay. What I'm going to do is I'm going to go into how we're going to take coding and the mechanic side or the electronic side. You marry the two together, okay, to come up with a component that goes into this robot. Okay. For a robotic arm, okay, you have a robotic arm. And we also have a hand in front of it. If you look at this hand that I have here, this is a robotic hand. In the hand, you find there are linkages, and there are also pulleys on this one. Okay, and then also how does this link move? And how does this pulleys move as well? What makes it move? Okay, is this black box you see here. That black box is the embedded system. In the black box is some electronics, and inside that black box also is an actuator, which Mr. Ibrahim has touched on. The actuator that actually pulls that arm in and makes it behave like the human hand, okay, is the servo. So the servo is the heart of this entire thing. Without the servo, there is no robotics. You must remember that. The entire motion of the robot is the servo. The servo makes the robot move. The servo will make the hand, the servo will make the arm move. Okay? The servo will make the head move, the eye close and open. All that there is an actuator which the servo is driving. The servo is basically an actuator. Then we have sensors, as Mr. Ibrahim has touched on. You get different type of sensors. You get light sensors. You get touch sensors. Then you get water sensors that you can detect there's water or no water on it. So you got all these pressure sensors, air sensors. You got all these sensors. So these sensors will come into a central computing box. This computer box will then send information out to actuators like one of them you see here, this two here. These are 2 hands, okay, to open and close these hands. Okay. Let's zoom more closely into this whole thing now. Before we zoom into it, what did you learn? In coding, you learn Scratch and Python. What we're going to do is we are going to just do Python, okay, and then from hardware points, what hardware we're going to use? We're going to use the Raspberry Pi. This Raspberry Pi is very powerful. Now, why do you want to use a Raspberry Pi? Okay. The reason why we use the Raspberry Pi, because this Raspberry Pi, okay, the way it's designed, is basically a mini computer. It's a mini computer where its hard drive is a solid-state hard drive which is sitting inside the thing. It's got flash on it. Okay. Then it's got USB ports. It's got a LAN cable port. Also, you can plug in a monitor. Okay, a high definition monitor, HDMI monitor. So it's got everything built onto it. And guess what? on this Raspberry Pi, we can also install the development environment, which is we can install Python or Scratch onto this. But we will work on Scratch, I mean on Python. Also, what is very powerful about this is that it also has a connector, okay, which is called a GPIO connector, which is a general purpose input-output connector. On that connector, we can connect the actuators, we can connect the sensors on. So what happens here is that on this Raspberry Pi, you can write software that will actually read the sensors, does some intelligence on the sensor, does some processing on the sensor, and then send out information on the GPIO ports to control the actuators to open and close valves and whatever you want to do. In our case, we're gonna control servo motors. Okay, so that's basically how powerful this is. Also, why this device is recommended is because if you wrap this up in a black box and you keep it, you put the keyboard and mouse also goes on. It's got a keyboard, it's got a mouse. It also has the HDMI monitor on connected. It's got a LAN cable that's connected on. If you put this onto a box and leave it there, if a student walks in, all he sees is a PC. So from grade R, if you have this in schools, okay, the student becomes very familiar with the hardware. If he's very familiar with the hardware, as he progresses to grade 7, 8, 9, 10, 11, 12, he now knows his hardware very well. If he knows his hardware very well, okay. But remember, Mr. Ibrahim was talking about just now, okay, about robotics, and basically what he was talking about is how do you use these things and what they're doing. My job is not what they do. My job is to let's design one of them. Let's build our own robot, because the world also needs electronic engineers in the future as well. And our role as engineers in the future are to design new robots, which will become a very demanding thing in future. Okay, so you need to be in touch with the hardware, how the hardware works, how software interacts with hardware. Okay, on not the level that Mr. Ibrahim was talking, but on a much more lower level where you feel wires, you see wires, you see lights. Okay, there is current flow, you see all this. And by putting all that together, which is another level altogether, and that is a very specialized level where students get involved in, if they're interested in the science and technology, where they want to not just use robots, but they want to design their own robots for different applications in the future, which will come up. All these goodies that Mr. Ibrahim has shown, who designed this? These are all designed by mechanical engineers, mechatronic engineers, and electronic engineers. All of it. In order for us to design this, we have to know the hardware very well. Okay? So we show you how we start from a very simple exercise. From the very simple exercise, how we build up into a product. I told you just now that in order for us, the robots that we have, it has a component which is fundamentally important to all robots. And what is that? Servo motors. So we have two servo motors that we require for this class. Okay. We have 4 switches. These switches are normal push button switches. Okay. We have a breadboard. A breadboard is a prototyping board, which what you do there is that, as Mr. Ibrahim has pointed out, it can be reused. This is why we give you this. So there's multiple projects that, if you're interested in that, you can build on this here. So what you can do is they have rows and columns on it. Okay, I'm not going to go into the details of that, but this is used basically to prototype, and I'll show you how we use this here to build this project here. Obviously, the most important thing in any project is what? Wires. You need some wires, there's some resistors that we need. Okay, so basically with these components that you see here, okay, we're going to show you a project working just now. Here's the servo motor. Now watch how I want you to pay close attention to how I am going to build this project from the bottom up. The first thing is I defined for you the hardware that we're going to use, which is the microcontroller. I defined that for you, exactly what we do. Okay, and how we're going to plug into it. That's the first thing. Now I've told you what we need. We need servo motors, we need breadboard, we need wires. Now what I'm doing is I'm going into the servo motor. Okay, so here's the servo motor. How does the servo motor work? In order to design the servo motor, this is a specialized field which is into control engineering. Again, the demand for servo motors is going to grow. So the fourth industrial revolution has created another job and another field of engineering, which is called control engineering. And it's going to be a very, very large field because every robot you design will require servo motors. The servo motor is a very interesting device in that all the controls of it is taken care of in the motor itself. I'll instruct the motor to say, I want to go 0 degrees, it will move 0 degrees. I'll instruct it to go 90 degrees, it will move 90 degrees. So like that, whatever instruction I send to it, okay, it will basically move to the angle for me. So if you got a hand to move 0 degrees, the hand will move 0 degrees, 90 degrees, and also if I say move 180, it will move 180 degrees. So that's basically what the servo motor will do for us. So what we need to do is, in order for us to attach this motor to the Raspberry Pi, we have to understand this motor from every level on how it works. So we have to understand from a mechanical level how it works, you can understand from an electrical level how it works, and we must understand from a programming level how it works. That's very important. Okay, from electrical level, this servo motor has a connector coming out. This connector that comes out here, what we have here is we have 3 pins that comes out into this connector, the black connector you see there. It's got a red wire, it's got a brown wire, it's got an orange wire. Okay. The brown wire is the ground wire, goes to 0 volts. The red wire, which is the middle one, it goes to +5 volts. And the orange wire, okay, is called PWM. Now, what is PWM? It's pulse width modulation. Oh, that is how I talk to this. On the PWM wire, I would send a signal through, and that signal will tell the motor exactly which angle I want to move. Now, PWM has been around in a long, long time. You see them a lot in motor cars right now. You see them a lot in your house lighting as well. And we don't actually keep our lights on all the time. If you keep it on, what happens is that internally there's a logic that switches it on and off very fast, okay? And it appears like it's on. So that's basically how PWM works, okay? And I don't want to go into the detail of PWM, but I'll give you a very quick breakdown of it. Okay, so here you have the motor. We gave it a wiring, which is on the top you see it, the wiring is here. And then this is what the PWM looks like. Remember, what I'm going through now is I'm trying to understand the servo motor. The understanding of the servo motor will enable me to plug the servo motor into the Raspberry Pi. So what they're telling us, where am I getting this information from? This information basically you get from the data sheet or specification of the servo motor. So the servo motor specification is telling us that every 20 milliseconds, which is the period of this, every 20 milliseconds, I must provide a signal with a particular word. That's what it means. Okay. So what it's saying is that if I send a signal every 20 milliseconds, okay, and the pulse that you see here, it must vary between 1 millisecond and 2 milliseconds. So if I have 1 millisecond on this, it will pull the whole servo motor to 0 degrees. If I make that pulse width to 1.5 milliseconds, then it will move it to 90 degrees. If I move it to 2 milliseconds, it moves to 180 degrees. So you can see now we're getting information from this diagram on how to control the servo motor and get it to a position we want. Also, they're telling us that the power applied to this, which is the red wire, it's between 4.8 volts to 5 volts, okay, in that window. So if you supply a 5 volt power supply to this servo motor, it's fine. Now, if they didn't tell you that, where are you going to plug the servo motor? You can't put it on 12 volts, it'll blow up. If you put it lower than that, it's not going to work. So basically, we need this information. Okay, so here's a diagram of exactly what I just told you just now. We have the servo motor, we have the timing. The timing is basically telling you if it's from 0.5 to 1 millisecond, the whole servo motor moves to 1 degree. If it's 1.5 milliseconds, it moves to 90 degrees. If it's between 2 and 2.5 milliseconds, it will be 180 degrees. So like this here, you can do a linear mapping of this to say exactly how to move it to any angle you want, 0, 45, 1 degree, right until 180 degrees. Most servo motors around moves from 0 to 180 degrees only. Okay, most of them. But you do get some that rotate 0 to 360. So we understood how the servo motor works. Now what we have to understand is from the Arduino point. Sorry, not from the Raspberry Pi point. From the Raspberry Pi, I initially pointed out to you, okay, as you can see in the diagram, there is a connector over here. This connector. This connector you have here is a GPIO connector, which is a general purpose input-output connector. We have to, on that connector, connect this motor in it. Why do we have to connect it to that? Because our processor or microcontroller is a Raspberry Pi. So our microcontroller sitting in here, it talks to this connector, and then we're gonna output, we're gonna interface to a servo motor with it. Remember the servo motor, what I told you. The servo motor basically has controls, okay, it has power, it has ground. Now, this Raspberry Pi we have, again, in order to move with the project, you have to understand the Raspberry Pi with regards to what it can give you, what it can't give you. Now, if you look at it, the Raspberry Pi itself has got power, and it requires 5 volts. So there is 5 volts on pin 2 and 4. Okay. So the question is, can we plug or connect the servo motor to the 5 volts? Can we connect it? The answer is maybe. Okay. Why we think maybe? Is because we need to look at the current requirement, because these servo motors, okay, draws quite a bit of current. Okay. They are drawing quite a bit of current. And if you start doing too much of current on this, what will happen is that the current basically comes from the Raspberry Pi, and eventually you can overload the power supply of the Raspberry Pi, and the Raspberry Pi will stop working. You can blow it out because you're trying to draw too much of current. In order to prevent all those problems, what we have done is we have put out an external power supply, which is a 5-volt power supply on the top here. We put this here, external, okay, and then we are powering that servo motor now with an external power supply and not the Raspberry Pi power supply. You see now how the design is coming out. Just by understanding from an electrical level, okay, that you can't just connect it. You will see that there are some practicals, some tutorials are telling you on the net to plug it in there and it'll work. Yes, it'll work for a short while, and after some time you'll find the Raspberry Pi will stop working. But remember, Raspberry Pis are not cheap, they're expensive. Okay, now do you want to risk blowing up the Raspberry Pi? No, you don't want to do that. So what you're going to do is, to be safe, you must understand all the interfaces and accordingly connect the device. So from there, we saw that. That's why we need the power supply. So you can see how the design is coming. We got a power supply at the top. And then the servo motor needs to have a ground. And we can connect the ground signal to the Raspberry Pi. We've connected there to pin 14. Okay. And also, what we need to do is the pulse modulation. We're going to use pin 22 of the Raspberry Pi connector and connect that to the this thing, the pulse modulation signal. So let's see how this works. Okay. What we're going to do is, now I'm going to show you how we're going to do the code. I'm going to stop sharing for a while to get the code up. Okay, so guys, now you can see we now going into the program. The first thing is we understood the hardware. Now we're ready to program. From a programming point, what we need to do is, okay, we need to control the servo motor. We need to see if the servo motor works. If it's doing what the specification says it's supposed to do. So the first thing is we need to import the GPIO libraries. This is Python. We're in Python, okay, and we need to import the GPIO registers. I can make it bigger for you. Okay, and this is why we got the first line here, which we can import the GPIO registers. The second line is we need to get the time module in. The time module basically is to enable to put delays in there. Like for example, we need to sleep for 10 seconds or wait 10 seconds. So we need to do that. Okay. And then what we're doing is that there is some warnings that will come up. So we think false for the warning. So we're not going to have any warnings on this. And then we're going to set up we're going to set more GPIO board. Okay. Now why we're doing this is that on the connector itself, you'll find that there are GPIOs and there are pin numbers of the Raspberry Pi. By saying set more GPIO board, it means that we will follow the pin number of the Raspberry Pi and not the GPIO numbering. By doing that, it's much more easier because you can see it and you can quickly go in and you can start putting in your wires on which pin number on a Raspberry Pi you want to put it, or it becomes very confusing. Now remember, the slide before this I had where what we did was we connected the PWM signal to pin 22. So what we have here is that we are saying that pin 22 is the GPIO setup, pin 22 GPIO out, which is the set output. Then after that, we're going to tell you what we're going to do. We're going to use that one as a PWM signal. Okay, so we said the next line is PWM is equal to GPIO dot PWM, and we say 22,50. The 22 is a pin number 22, and the 50 is telling you what frequency. Now, I put in 50 hertz. Why did I put 50 hertz? I put 50 hertz because the specification said 50 hertz. This is what happened. The specification said you must use 50 hertz. What's in 50 hertz? 20 milliseconds. Now, you can see again, I can only put the number if I understood the servo motor. And the servo motor specification said 20 milliseconds. And that's how I got the 50 hertz. Okay. And what I'm doing after I'm saying PW start. When I say start, I'm putting 0 in it. That means it is 0%. Okay. It will then take the servo motor and move it to the location 0 and keep it there. Then what I've done is, you are familiar with Python. What I've done is I've created a function over here which is called set angle, and then in there it requires a parameter called angle. Here's the duty cycle of it. Okay, here's the pin number which I want to use, and then I set the duty cycle with this. Now the angle over 18 plus 2. How do I get this? If you remember the slide I showed you previously, where what we've done there is that we said between 1 millisecond and 2 milliseconds. Okay, between 1 millisecond and 2 milliseconds, we have to map 0 degrees up to 180 degrees. So hence the 18 of it. Okay, the 18 is basically 185%, and then the plus 2 will give you the offset, because we're not starting from 0 millisecond, it's starting from 1 millisecond. So the 1 millisecond that you see will come down to 2%. So that's the offset. And then what happens here is that we will then switch the PWM on, just by calling the function. That's only a function. The actual test of it is here, where what we're going to do here is that we got set angle. We're going to set it to 0 degrees. So we should see the servo motor moving to 0 degrees. It will wait 5 seconds. It will then set it to 90 degrees. It will wait 5 seconds. We'll then set it to 180 degrees and wait for another 5 seconds. And once we do this here, this will basically prove to us that our code is working and we can talk to the servo motor. Okay. And what will happen here is that when you finish, we must make sure that we clean up the GPIO ports and we must release them. So that's basically what we have done. Let me just show you the output of this. Okay, so you have the Raspberry Pi, okay, and then here's your actual Raspberry Pi over here, and here's the connection of it, and we have the orange wire which is on pin 22, the black wire which is the gray wire which is ground, and then we have the red wire which is going to my 5-volt power supply which is external. This is then connected via this connector going to my servo motor. So here's my servo motor here. Here's the city here. Okay. And then you will see just now with the code, what we'll do is the code said 0 degrees, 90 degrees, 180 degrees. So you'll see that just now moving through when the code is running. Just to give you an outlook. And then here's your breadboard. This is the power supply. I've got the external power supply that's powering the servo motors. Okay. staying long because of it. So that is 0 degrees. This is our Python code running, right?
Sorry, they can't see.
Can't see the video.
You can't see the video, am I right? Natasha? No.
Can't see.
The output. He's showing a video at the moment. Can you see the video? Yeah, they can't see the video.
Okay, let me stop sharing that. Sorry about it, guys. I think.
Okay.
Stop sharing this. Okay, guys, this is the video of this, and then it's basically connected, showing the connection of the Raspberry Pi to the servo motor. Okay, so here's your servo motor here. Okay, so here's your GPIO I/O connector where it's connected to, and this is your external power supply. And see, we have used the breadboard over here to connect the power supply, the external power supply. And just now, what you notice just now is that we will now pulse send the same code that I showed you just now is running on this Raspberry Pi. That's going to rotate this the servo motor to 0 degrees first. You see it moving now. That is 0 degrees. You can see it's waiting because that's your 5-second delay I've got in between, which gives you time for the motor to find its way. That's 90 degrees. And then it will move to, that's 180 degrees. So what we have done here is that we've shown you, yeah, let me stop sharing, go back to my presentation. Okay, let me show this again. So we saw that working. So we saw the servo motor working, and we saw how the Python code, okay, ran, and the Python code basically, the output of the Python code that we had that was sitting on the Raspberry Pi was controlling the servo motor. Okay. Now what we're going to do is we go on to the next part of it. Now we're going to take the breadboard, and we're going to connect 4 switches. You can see how we're slowly building up the project. So what we have here is that we have the breadboard, and then we have 3.3 volts, which is coming out on the connector here, which is this first connector coming up there, and it's connected to your power rail on top there. Then we have the ground, which is connected here, and then we have the switches. We have 1, 2, 3, 4 switches. I'll explain to you later why I'm putting these switches. Okay, so that's one switch. That's the second switch wired. So you can see what we're doing. We're connecting it between 32, 36, 38, and 40 of the Raspberry Pi. Okay. Let's connect the next one. Here's the next one. Okay. And then here's the last one here. So we've got 4 switches connected. Okay. Now we got the switches connected. And what we're going to do is, very interesting thing to note here is that, again, for us to understand the microcontroller. The microcontroller itself, the I/O pins of the microcontroller, they're not 5 volt pins, they are 3.3 volt pins. That's why we have we take instead of using 5 volts switches, it's 3 volt on a switch. Okay. So again, from an engineering point, it's very important for you to understand, for you to understand your processor, your I/O that you're plugging in, that you must not have incompatibility. If you have incompatibilities, you're going to blow up a device. You'll blow up the microcontroller or something, you blow it up. That's why read the specification. Okay, you have to read the specification and understand it. Okay, so we got the switches, and this is connected on the breadboard. Okay, next step. So how does the switches work? In order for us to test the switches, remember we connected in the on the GPIO I/O pins. We got it connected there. Now what we're going to do is we're going to write some Raspberry Pi, some Python code to now read the switches. So let me stop sharing and I'll share it. Go back to this quickly. Again, you need to have the GPIO libraries imported, which you got. We have to have the time libraries, which you've got. Then we set the warnings. Okay, again, we're doing the mapping to the actual pins of the Raspberry Pi to the device. This is why I got set more GPIO board, which is this line here. We've got that. And then here's your 4 pins, 40, 38, 36, 32. These are your pins. And also the very important, the interesting thing here is that these pins are programmable in which way, in that you can, in software, you can enable resistors to be pull up or pull down on each pin, which is very powerful. Because if you forget you don't have a resistor, you can in the software go in and say, I want on that pin, I want to put a pull up resistor. And if I want to put a pull down resistor. It does it for you. It's done. Instead of getting a physical resistor and putting it on the Raspberry Pi. So here's your 4 pins. So what you've got here is you've got a loop. You've got a loop running here, which is forever. And what we do is we're reading each one of them. Okay. When you press the switch, it'll read back a 1 or a high. When it reads high, it'll show you on the screen, right out on the screen, that button 1 is push. Okay. Like that, it goes to each one, and button 2 is push, button 3 is push, and button 4 is push. So what I'll do now is I will show you the code for this, the output for this. Let me stop sharing this so I can read properly how I did before. Okay, so here's the wiring of the breadboard. Okay, this is how it's wired. These are 4 switches, as I showed you just now. These 4 switches are now connected to the GPIO ports. You can see them connected there. Okay. And here's the 3.3 ports also connected. Also, what I've done is I've left the servo motor on here. You're not going to see it here, but it's in the side on the left-hand side of the video. It's there. And I'm going to push the buttons, and then you'll see on the screen, on the Raspberry side, it tells you which button is pressed. You can see it. And as you press it, you can see the different ones will come up. See, button 1 is push. You saw this in the code just now. Okay. By the way, what you're seeing on this video, okay, is the entire environment where you have a screen connected to the Raspberry Pi. It's not a PC on its own. It's the whole development environment. It's sitting together now. So this is why I'm saying that if you've got a student that comes in from grade R going up, if he knows the whole system with regards to, and he's been using it all the years, it's very easy for him to actually build projects on this. Okay. So here's the breadboard again with the switches connected. Okay. So you got your 4 switches. Okay. Okay, so we saw the servo motor working, and we saw the switches working. Now, putting it all together, here's the switches, and then here's the servo motors on the top. Let's connect now the servo motors together with the switches. What we need first, remember I told you why we need the power supply, external power supply, because we don't want to overload the Raspberry Pi. Again, if you look at this, we've got 2 servo motors that we want to put on. These 2 servo motors that we're going to put on, okay, is going to draw twice the amount of current now. And the Raspberry Pi do not have enough current to drive. Okay, so we don't want to blow the Raspberry Pi up. Remember, the servo motors, okay, it has 3 wires, you've got 5 volts, you've got ground, and also you've got your modulation. So here's your modulation signal. Okay, here's there, the 2 of them, and we're connecting them on pin 18 and pin 22. Now pin 22 is familiar. Why is familiar? Because pin 22, we used it just now to test the servo motor on its own, which we finished too. Okay, so now what we're doing is we're adding another servo motor to it, which is on pin 18. So we got 2 servo motors, we've got 4 switches. Okay, and this is now the whole project. Now what we're going to do with it, Okay, the first thing is let's test the switch, the both the servo motors together. Let's see how it works. Okay, now you can see what's happening. The code is getting more complicated, but you see how it's getting complicated. Huh? In fact, it's not complicated. Why? Because we are incrementally building this code slowly. By doing it slowly, now you understand the project and what we're trying to do. So what I'm going to do is that we're going to test the two servo motors. We tested one servo motor, now we're going to test two servo motors. Okay, and then we finish test the switches. Then I'll show you the integrated product just now. We almost did. So again, on the top, I'm not going to go through this again with you where we define the GPIOs, there's a timer module we need, we set the mode to the physical numbering, I've done that. The additional thing what I've done here is that I've added over here the other GPIO here, which has been 18. And what I've done is, I'm not calling PWM, I'm calling it PWM fin and PWM right, WR. Now, if you look at this, the first one is set at pin 22 and it's 50 Hertz, which is 20 milliseconds. Here's the first one, and we say 0 to that. And then the second one is basically pin 18, and we call it, that's also 50 Hertz, because both servo motors are identical, the specification is the same. Okay. Then I've got two functions. Before I had one function, both the functions are identical. Okay. I just rename it to set angle fin, and then here's your calculation, which is exactly like what you have done already. I just rename it. And I call the other one set angle WR, and again, it's set up like this. Okay. And then what we're going to do now is that if you look at this code, we're basically going to move the fin to 45. We're going to move the WR to 0, and we're going to move 90, the fin to 90, WR to 90, and we're going to move the WR to 180, and then we're going to wait. So what does this output look like? I'll show you now. Now the project is becoming very interesting now. Okay, what I've done here is I've got a robotic arm. It's got two servo motors. Okay, here's the one servo motor here, and here's the other servo motor. Here's it moving. Here's the two angles. But you move that one, which is that was the fin. One, and then you can also see it's got two dimensions. One is there's a claw that's moving, which is your fingers, and then you've got the wrist, which is moving. Okay, which is moving from 0 to 180. The wrist. And then you've got the claw that opens and closes. So you see it gets two motors. Now you can see where we're getting to now. You can see how we're building our robot, where we started from and where we're getting to. We're building our own robot. You can see that. Okay, so that's where we're getting to. So now what we're going to do next is that we're going to go and integrate this with what? With our switches. Okay, now we're going to integrate this with our switches. The switches that the switches that I showed you just now, the 4 switches. Okay, now instead of the software going in and changing the angles, what we're going to do is by pressing the switch, we're going to tell the switch to open the claw, open, but to close the claw. We're going to press the switch and say rotate left, rotate right. So now you can see what we have done. Tested each component. Okay, we went into the details of looking at how they are connected from a wire level. We went into details looking at from a signal level what it requires to work, what is required for it to work. So we have done all that. And now what we're going to do is we're going to integrate the whole thing to build up a product. So what we're going to do now is I'll show you the code quickly for what we're going to do. Okay, the code is quite simple in what we all you see on the top here, okay, is what we have finished done. What we have done now is that you can see now we got a marry of everything. We've got the switches, there's a day, and we've got the GPIO together. And then what we're doing here is that in the main program, what we're doing here is in the while true loop, which we're going to set forever in, we check for the switches. Here's it, 1, 2, 3, 4 switches. The testing on the switch is finished too. So we have confidence that the switches work. We know it works. See, this is how engineering works. You can't just while you're waiting and it works. You have to do it in a very systematic way. You got to first take each component, see if it works, each component. And this is how you start understanding the project. If anything goes wrong, if someone tells you the switch is not working, you know exactly where to go back and look at what's wrong with it and why the switch is not working. If the servo motor doesn't work, you go back and you see why the servo motor is not working. You can go back and retrace your whole steps. What we got here is that you can see over here is that when the switch is pressed, let's take the first one, it'll tell you that the first button is pressed, and then after that, it waits till you release it, because if you press the switch, what happens? It continuously picks that the switch has been pressed. So you must leave it. The moment you leave it, okay, it will move the one servo motor to 45 degrees. Okay, and then you can see what I done for the two switches, which is switch 1, button 1 and button 2. It is linked to the Z angle fin and Z angle fin, which is the one servo motor, but different angles, 45 degrees and 90 degrees. And then this is basically the clock. Okay, it will like open and close, open and close. And then for the other switches, what we're going to do here is that we're going to make it rotate clockwise and anti-clockwise. So you got this clockwise, anti-clockwise, and then you can press the clock like this. So for those ones, okay, you'll find that we got button 3 and button 4 connected to that. If button 3 is pushed and then released, it will go to 0 degrees. And then if you press button 4 and release it, it goes back this way. So that's basically what happens to this. This is the software that we're going to test as our product that we want to show you. Okay, so let me stop sharing that and I'll put the video up quickly for you. You can see this. Okay, we got the switches wired. It's all wired into the Raspberry Pi. You can see that. And here's the power supply for the servo. Here's the arm that we built. It's got 2 servo motors on it. Okay, one in the bottom that rotates it clock and anti-clockwise. Is one on the top that opens and closes the clock. See, now we push and leave the button, and you can see it opened. I'd like that they will go to each button you press, and you see the claw opening and closing, and it starts rotating. This is showing the construction of how this thing works. That's a rotation. That's 0 degrees. That's 180 degrees, and you see the claw opening and closing while it's moving left, clock and anti-clockwise. Again, guys, you can see it's not complicated. These building blocks that we have here, all this is in the robotic kit. Okay, so the schools will be provided with the kit. The kit is there. All we're trying to do is we are from a technical point, we are re-looking the entire from a different level, rather than just plugging each component in, following instructions. Okay, like robots, following the instructions, and they tell you to press this button and see what happens. See, we are not doing it. The button was pressed, the claw is open, claw closed. So we are not doing it. Okay, what we're doing is we are understanding each component. We're understanding every component in this design, and by understanding the components, we are able to build our own robots and also control whatever we want to control. that's basically what we want to do. Now, what I want to show you next. We basically, let's see how it works, okay? And what happens here is that if you go back, this is basically the project. The project, what we did was, we basically wanted a robot, we designed a robotic arm for you, which you can open and close and rotate it left and right, clock and anti-clockwise. What components we needed? We needed the switches, and we needed the two servo motors. These are the switches, and we needed the servo motor. But remember, it didn't work this way. What did we need? We needed a Python code for this. So we had read Python code. So we needed a code, and we took this hard way. We married the two together, and we've got this. Now, if you look at this whole thing, it doesn't stop here. Like I just told you initially, and Mr. Ibrahim has been telling you as well, with regards to the fourth industrial revolution. This is how you're supposed to be thinking all the time. It doesn't stop here. What we basically designed up here is a remote controlled robotic arm. That means I am standing there, and these four switches are like a joystick I have, and I can move this joystick back and front. The joystick basically have exactly these four switches on. Okay. So here's the joystick, you move left to right, top and bottom, and as you move these things, these are switches that move back and front, and it will move your arms around. So it doesn't stop there. Why doesn't it stop there? Let's take the switches out. If we take the switches out, what do you get? All you have is a servo motor. Okay, and then what we do is we plug in a module onto the Raspberry Pi, and that module can be a Wi-Fi module or a Bluetooth module. The moment we do that, we've now taken this robot into the next generation. What is the next generation? The next generation is what Mr. Ibrahim has already spoke to you about. The next generation is IoT, Internet of Things. Internet of Things, and what happens there is that there's no more switches. The switches now becomes your laptop or your tab. That's what it becomes now. And then by means of your tab, there's an app that you write. The app that sits on there now will send information to the Raspberry Pi. The Raspberry Pi then picks it up and will control this robot. You see now from where to where we went. We started with a remote control arm. The remote control arm now becomes a wireless arm. That wireless arm now translates to IoT. IoT. So, IoT is. Yes. So it's the Internet of Things. So what happens there is that we're now talking to the cloud. So this two servo motors as of our arm that we have there now basically is in the cloud. So when it's in the cloud, what happens is that now you can log in and you can send information to this Raspberry Pi and you can start moving this thing remotely. But whatever you do, this low level will still remain the same. The low level from the Raspberry Pi talking to that motor is not the same. You see what I have designed now? I have designed my own robot and I put it on IoT first. So there's IoT component in it. So you see how I've evolved the product to where I want it to go. I can sell this product. It's my business now. I can sell it. I make money out of this. And I live on this. So this is a new job for me. This is how the world is going now. This is how you're supposed to be thinking. Okay. And also, this where you take the buttons off and you start remotely controlling it. There's an application which I've seen, and when I was consulting in the hospitals, what happens there is that if we take the servo motor out, it's basically a robotic arm. Okay, it's a complete arm. That arm is now controlled by IoT. And where he uses in hospitals is that the surgeon who is sitting on one side of the world needs to operate the patient on another side of the world. Before he travels there to do the operation, the guy could die. So what they do is, if they have this in place, by the way, they do have this. Okay, what happens there is that the guy basically sits at his house, wherever he's sitting, and he can see exactly the patient sitting on the other side of the world, and he then, via IoT, he then sends information, and he can control that arm and operate that person without him physically being there. You see, this actually opens up an entire different field of of engineering, also in IT as well, because you must remember something with IT, okay, is not just sending information back and front. From an engineering point, engineering has redefined the IT, because if you think about the application I just spoke to you about now, which if the doctor moves his finger remotely 1 millimeter, you want it to immediately move 1 millimeter other side of the world. That means it has to be super fast.
That's why we need 5G.
You really want to say that?
Yeah. Why we need 5G?
Mr. Ibrahim is basically telling me that I must tell you how we get this, okay? But it's not guaranteed. Yes, it's only remote test. But this is why you need 5G. The 5G gives you that bandwidth and also the speed of the network. It gives you that speed that it can happen immediately. It's very fast. Okay? It's like watching it in real time. If you look at this right now, me talking to you, I move my hand. After 1 second, you see my hand moving on the other side. Okay, so we still have challenges, and these challenges, guys, your students need to know about these challenges, and they need to be excited about these challenges, and that excitement are going to bring into this world new engineers, new scientists, new doctors. See, doctors, it's affecting the medical field as well, because if you look at this now, I mean, the doctor doesn't want to go from, say for example, a doctor is in India, he's an expert. Right now, okay, he's an expert in India, and India has got this virus now. You can't call this doctor to marry, okay, because he's going to bring the virus across. But yes, he's an expert. But in America, if someone needs an operation done urgently, this guy can't do it without him because he's acquainted. The robotic arm is there, he sits there and he controls. Okay. Obviously, it's not going to be as simple as this. It will be much more complicated than what I told you. But this is basically a very basic application that I've taken, and I found that there was a lot of value in the thing with regards to very simple 4 switches, 2 servo motors, and we showed you what we can do with this here. Okay. The applications are endless. You can just sit back and just think on what you can do with this thing. Okay. There are so many possibilities out there that you can use. It affects teaching. It affects engineering. It affects medicine. It affects cooking. Okay. It affects every part of whatever industry you work in. It affects the banking facility. It affects the commerce. It affects everything. Okay. Thank you, guys. Okay.
Go to Q&A. Pull a chair. All right, I hope you guys found this sessions interesting. We tried to give you an overall view of exactly what is required and how to get it done, and also giving you a practical demonstration of how it works. So I'm going to open it up for questions now. So if you have any questions, and then I will we have some time, and I will try to lead some discussion on how we can move forward and what are the new things that are happening and what you would like to see happening, things like that. So I'm going to open it up to you. So if any one of you have any questions, just going to open up the chat as well. Put your mic on and ask a question. Be fine. Either Natasha, Imtiaz, or myself will answer your question. Or you can ask on the chat as well. Remember, there's a chat button with Zoom at the bottom. You can click on that, and whatever you type in, we'll be able to see, and hopefully I'll be able to answer your questions for you. Anyone? So you're either sleeping or you're not there. Hopefully you are there.
What we will do is, if you have no questions, what we can do is, maybe, Ibrahim, I don't know if you agree on this, we can maybe give them our emails, and they can drop us.
Yeah, we'll put that on the we'll put that on the message.
You can ask us questions, okay? I mean, sometimes you may, you may think about it later on and come up with some questions that you would like. Mr. Ibrahim will our email addresses, and then you guys can respond to us. And sorry, we'll respond to you.
Remember, coding and robotics needs to be fun. We don't want to make it like a math subject where, you know what, nobody wants to do it. So if you want to do it, it's fun. You must get involved in it. You must be able to love it. And then you will find that you will get the true value out of it. Natasha, you have a question? Would you be open to exhibiting your work at Africa Tech Week in African Teen Group? Lockdown, Digi School? Yes, of course. Why not? Let's talk about it. I think that will be happening. Is it virtual or is it face to face or mask to mask rather? Lockdown. You can put on your mic and you can just have a chat about it quickly. Sorry, if you said I don't know your name.
It's Tabiso. Tabiso, you can go.
Sorry, Natasha, we didn't hear you.
Can you hear me now?
Yeah.
I think it's Tabiso. Tabiso, you can unmute and ask the question.
Tabiso, we would love to. If you can just give us more
Okay.
information.
Okay, thank you very much. Then we'll contact you. That's just what I wanted to ask for my side. So if you guys are interested, then we'll definitely make contact with you guys after this.
Perfect. Yeah,
Thank
Natasha has our email addresses and our numbers as well. We'll also put it on the chat on the side.
Okay.
All right. I think I also want to lead a discussion while we're waiting for questions. If there's anybody, you will notice that we spoke about school a lot, right? We didn't go into what happens after that. The universities, we said there's mechanical engineering and electrical engineering, and mechatronics, etc. I was in a meeting yesterday, I think, with the guys. We have a collaboration effort with Tianjin Vocational Institute in China. And we've developed with them basically on the IT side, 2 new programs. A higher certificate in IoT, that's the Internet of Things. And taking that further, we've also developed a 3-year degree on the Internet of Things.
Okay.
So you're coming out of school,
Yeah.
you're going to move into one of these particular areas. And I think we are one of the first universities that has already developed a causeway. It's already been handed in for submission. It goes to, I think, Department of Higher Education and Training. Unfortunately, they take about a year or 2 years before they give us permission to do that. But it has already been developed and sent in. So within the next year or 2, students coming out of school will be able to do specialist degrees in IoT, etc. Also under the mechanical engineering, okay, where we have what we call additive manufacturing, like your prosthesis that you
Yeah.
teach, like how we can manufacture that artificial leg. And at our university, we have the capability of doing that because we have a fully spec 3D printing there. And now the engineering department, which is mechanical engineering, are developing an entire 3-year degree around additive manufacturing and 3D printing, because there is a need for that type of thing. And I know you teach prosthesis, so maybe you can just explain to them a little about that as well.
So from a prosthetic side, I actually take I've got some students on prosthetics, which I take them. And there's a lot of, it's an up and growing field. And when my students come in, okay, the first thing I tell them, if you want to understand, in fact, I don't teach prosthetics, I teach electronics prosthetics. Okay? And I tell them, the first thing I tell them is, before you come to my class, I want you to go watch movies. I want you to watch movies, and guess which movie I tell them to watch? Robocop. Now, Robocop, if you look at it, it's fiction, okay? But it's a reality now. It's a reality because now if you look at prosthetics, with regards to human beings who have lost their hands or legs, whatever it is, okay? If you're a bit old, I mean, when I talk about old, like you're like 65, going up to 80, and if you have a stroke or something like that, it's very hard for you to wear the current prosthetics in place because you need a lot of energy to move those arms. Okay, so what happened is what is taking place very, very fast. I mean, over 3 or 4 years now has taken place is that those prosthetic arms now are robotic arms. They're robotic arms, and you won't believe it. The sensors that we put in are basically attached, non-invasively, attached to your body, and those sensors basically pick up your information that's going down your nervous system. They pick that information up, puts it into a computer. Okay, when I say computer, I don't mean a big computer, it's not a embedded computer, similar to the Raspberry Pi. Puts it in there, and it starts moving your arm. Okay, however it is, if you think that you want to move it right, as you pick up behind, it starts moving right for you. With very, very less effort, very less effort. Now, exactly what I've mentioned to you now, in regards to the sensor that picks up the information is then put into a computer. Now, from electronic engineering department point of view, on the university side, what we have done is the computers, the base computer right now, the architecture for that, what they use is this processor which you have heard before called ARM, ARM. Okay. Now, ARM basically is the universal microcontroller that's being used everywhere. So we started teaching this 2 years ago, okay, and it has become a huge demand in industry right now, and it's such a huge demand that there are shortages of silicon to actually produce this controller right now. Okay. Your Raspberry Pi is an ARM microcontroller. Your Arduino is an ARM microcontroller. The watch I'm wearing, okay, inside is an ARM microcontroller that measures my pulses for me. It's in here. Okay, so everything is ARM. So we, from the university point, we have brought our students to that level. Okay, to that level where we are preparing them for 4IR. But the question we are saying now is that if we are preparing for 4IR, we are doing it. I require students from school to come to us who are prepared and have prerequisites so that we can train them on another level. Because our students, remember, are coming to us with no experience on this from schools. So now I'm glad, Ibrahim, that we're doing this. That the students now from school are going to come to us, and guys, if you actually marry the two together, it's like great. We're going to have some great input to our economy, okay, which is great, and also guys who are unemployed will be employed now. They'll have it's a totally different field altogether.
We have to look at firstly upskilling and reskilling as well. Apart from what we are doing here, these are the kids that are coming through from the schooling environment. Okay, so they're going to come into some knowledge into one of our programs, and we're going to develop them with the new skills.
Yeah.
The problem is also the other aspect of it is that there are people already out there that are working that we need to reskill and upskill, otherwise they're going to lose their jobs.
Yeah.
Right. Like for an example, Standard Bank retains a whole lot of stuff. We have a Standard Bank in the corner here that's not anymore. Yeah, the branch is shut down. So what happened to those stuff? Okay, one of two things. If they could not adapt to the new environment, they lost their jobs. That means they're sitting out of work right now, unemployed. Okay, or Standard Bank took them and retrained them for another job out there. Okay, so reskilling and upskilling becomes very, very important. Right? Because as I will just tell you right now, just in the security area, okay, within the 4IR, security, by the way, is absolutely critical. Everybody seems to hack everybody else these days, right? I think we were just talking about it before we even started the session, where Imtiaz asked me, did you notice that the network seems to be down at least a couple times a week now? What's going on? Could be somebody's hacking them. Right? So right now there are more than 3 million jobs right now in the security field.
Yeah.
The jobs are there. We have millions of people unemployed, but those millions of people are unemployed cannot fit into those jobs because they do not have the skills. Okay, so we're going to have to build skills. That's where short courses come in. One thing is about doing 3-year degrees and diplomas and that type of thing and improving your qualifications. But a 40-year-old person or 50-year-old person, they need to reskill themselves or upskill themselves. We also need to look at developing and creating short courses for them.
Yeah.
And so that they can quickly upskill within 3 months or 6 months. And there are a lot of organizations like Microsoft, like Cisco, like ARM themselves who offer short courses in these areas. And remember, you need to start small and you need to build. Just like how Imtiaz built that ARM and showed it to you, this is now going a bit further. Right? Putting that arm on a vehicle, right? Programming it further, getting more and more complex as you kind of go along, I would guess. So education is very, very
Very important.
Very, very important. And there are different areas. Like I said, the formal education, which is your degrees and your diplomas, you come out of school and you go into there. Then the informal qualifications, like your short courses. And right now, most of your courses are online.
You know, the one thing, Ibrahim, I think that is great is that the
I'll answer that.
what is great about the whole thing is that if you look at the 4IR and the components you need, okay, from a software point, we've got this thing called Python. Really how the engineering for us is not Python, if you see. C++. That's what we actually program in a lot, okay, because we go into the low level. And then if you look at it, there is software development that goes with that. There's a software environment. There's a hardware that you need. But the good thing about the whole thing is that a lot of these huge companies, like for example, STM, okay, huge, and the open source thing, they have actually given us the opportunity to actually play with these things and say, use the software for free. Use it for free. You don't have to buy anything. So you get the software, you download it, you install it, and you can start working with it without any licensing issues, nothing. You just carry on working at it. And this is a big advantage for especially our country or continent in Africa, where the resource of money is always a problem. So what we do is, if it's open source, we install it. Okay, and Microsoft also is going the route where they're also giving some of the software and making it open source and freely available to us that we can use it. Okay, the entire environment to code on this Raspberry Pi, okay, it's all for free. It's an open environment. Okay, the software that I developed and the product I showed you just now with the ARM I showed you, that entire environment, okay, Raspberry, that's open source, is for free. Okay, Python is open source, is for free. So you can see there's no reason to say I can't afford it.
And you can see we are proponents of open source out here. We are then myself. Everything that we do, we try to keep it open source because it's free. And also, there's no IPs involved. So you can take something, modify it, change it to suit your needs.
Yeah.
Unlike the proprietary guys. And I think the proprietary guys are learning as well. They're losing a lot of business to the open source. But obviously, there are advantages and disadvantages of both.
Yeah.
I think Geneva has a question. In this new qualification that you are trying to approve with higher education, is the option for online tutoring? Well, online tutoring or online, I'm not too sure what you're asking there for. Are you asking for a job, by the way, Geneva? Do you want to tutor for us online?
Natasha, with regards to Python, will Python be sufficient for grade 7 to 9 level to run these components? Yes. You can run Python to a high level.
I think C and C++ when I think university level.
Yeah. You see,
when you come into engineering as such, or when you come into computer science or IT,
if you look
the
at
grounding is important.
Yeah, you see the base language for all is the base language, for example, for Python, okay, is C and C++. It's written in C, C++. Python is written in that language. There was a language written to write this language. So the advantage that myself and I have is that because we come from the old school, we've been taught at this very low level, and right now C and C++ it's very difficult to get. So we can call ourselves privileged for that. Yeah, and that we came up with the hard way.
We would love to do some 3D printing workshops at DUT. Natasha, yes, of course. Great. We've got some of the best equipment in Africa. We've got a lab that is, well, we don't have one printer. We have, I think, let me just admit, Chris. We have a lab full of printers with different types of printers. So your PLA, your SLA, different types of material. The lab itself, we spent about, I think, close to 20 million Rand in developing that lab. Okay, so we believe we are very proud of it, and we believe that it's one of the best in Africa at the moment. Remember that also what's very, very important is that we cannot do things on our own. Like using Tech Geek, I think it's called, sorry, that we have done. Like they could not do it on their own. They had to collaborate. I think you guys had guys from TVET, you had guys here from DUT, And they all work together nowadays to prepare and present something. And I always say collaborate or die. Okay. And at the university, we have a number of collaborations and partnerships, for example, with MIT. We have a huge partnership in China, which is called the Luban Workshop, which is with Tianjin Vocational Institute. That is where the 3D printing lab comes in. Okay. And it's more for industrial use, commercial use. So building prototypes, getting stuff out there as quickly as possible. And for us, mostly to expose our students to the latest technologies. And yes, we run short courses as well. There are competitions that are being created. And it's not only competitions within DUTs, competitions between China and South Africa, basically. And DUT was the only I think the organization in South Africa that can host what we call the Luban Workshop. Okay. Now, remember, all this also leads, we spoke about formal education, we spoke about informal education, but what's also very important to me is the innovation and the entrepreneurship aspect. Yeah. Right? Because you guys are going to become innovators. You're going to open your own business. Why can't a 10-year-old or an 11-year-old or a 12-year-old start their own business right now and make money? What is wrong with that? We just got to provide them with the skills. Right? So we're looking at innovation and entrepreneurship. What is your idea? Come to your idea with your teachers, to your peers. Let them look at your ideas. Okay, ideate, design, build, test. All right, and there is a lot of government support for innovation and entrepreneurship as well.
Good vision.
Good vision. Yes, just at DUT alone, I think we've just accommodated or budgeted for, I think, a 42 million rand building that's just going to be for innovation and entrepreneurship. So if anybody out there has an idea, you can bring it to us. We will what you call incubate you, right? That means look after you, right? And basically build you to run your own business. Okay. We also ran a program called, I think we're going to run it in June, I think 19th to the 23rd as well of July, during the school holidays. It's called Code Like a Girl, right? Where we last year in December we brought in 300 girls, very successful from deep rural and rural areas to DUT. This year the budget is for 500 girls. Right? I think 300 of them will be based at DUT. I think 50 in Maritzburg, Greytown, etc. And here we are targeting basically the rural, semi-rural and deep rural areas. And this is for grades 8 and 9 girls. Okay, we accommodate you, there are prizes, you get breakfast, lunch, and dinner. We train you in 1 week in HTML. Okay, and the idea is to take that knowledge that we have given you back to your area. Because you got a spaza shop out there. You got somebody running a funeral parlor, a recycling parlor. Build a website for them. You've started your own business. You have now become an entrepreneur.
Yeah,
that's the whole idea. Okay, and I am running that with those workshops as well. That we run with Department of Education, KZN, and the MEC's office, Vodacom, which are our major sponsor, and the Durban University of Technology, basically. And we would love to get DBE involved. Natasha, maybe you can come in and help us with that as well. Right? So we are looking for partners and we can tie it. And we want to roll this out not only to KZN, we want to roll this out nationally. And you've got the support of Vodacom to roll it out nationally.
Yeah, but you know, in saying all this here, I think the most important thing is if you look from a university level, and I'm just talking for DUT right now, but I don't know if all other universities do this, in that our course and our content of course and where we're going to is basically guided a lot by industry and what industry requires.
Oh, yes.
There's a lot of collaboration between industry and us, and the requirements come from there. Also, what we would like to see is a collaboration between us and DBE.
Well, that started because Natasha's in.
Right. We come and we require, exactly what I was telling you, is that the example I went through, I mean, I want students who are almost there to take them in and to take them to a higher level. Because right now we're starting with the students from scratch.
Yes.
Well, this scratch, not the language scratch, but from
the bottom level.
The bottom level where they know nothing and we bring them up. So like that day, if we have this collaboration, then we know we're getting students who have good skills on this, and we can take them to advanced level.
We're starting them at the 6-year-old, 7-year-old, and we're building them up, right?
I'm hoping that
supporting them.
this relationship we have, or we kind of build with DBE, that we can close the gap. Because we got a big problem with DBE.
What we find at university, there's a huge gap between kids coming from school and when they come to university, and we need to bridge that gap. And the only way we can bridge that gap is by talking to Department of Education, Department of Basic Education,
but not only
in conjunction with industry.
But not only that, you see when we in our introduction, what we said was the first, second, third, and the fourth industrial revolution. And what I said after that was that for every one job lost, there's 20 other jobs that open. Okay, how does we know that? They don't know that.
Exactly.
So we need to tell them that these are the 20 new jobs that are opening, and start scaling the school. So they need to start changing that. You understand what I'm saying? The communication needs to happen all the time.
Oh, there's some nice comments from Chris. Hi, Chris. Chris, you can put your mic on and your video on and say hi. We'd love to see who you are. Chris says, 8-year-old entrepreneurship. Love that. Yeah, we're trying to get that done. Natasha, entrepreneurship skills and how it fits into curriculum. Yes. Remember, every student at DUT has what we call Gen Ed modules, general education. And that's where things like entrepreneurship skills, basic computer literacy all comes into that. So every student has a little bit of, or enough knowledge to be able to do something like that. Chris says, also super interested in the vision of closing the gap. Digital divide between schools and tertiary. Yes, that is huge. We need to close that. Remember, there isn't a digital divide between schools and tertiary. There's just a digital divide out there, right? Between the rich and the poor, the people in the city and the people in the rural areas. That we have to close. We're going to have to close that gap. And remember, a lot of the problems out there is out in the rural areas as well. And that's where a lot of opportunities are there for that innovation and entrepreneurship. So Chris, who developed your general education curriculum? I think we have a team of specialists at DUT, and we develop our own curriculum that then goes to DHEAD for approval. But we would add, with that comes the industry, what we call industry liaison, where each department meets with industry or representatives from industry. I know in my department, we meet once a term. And whatever we are doing, we are moving forward, new curriculum, etc., is first handed over to them for approval or comment before it goes to DHEAD for approval.
You see, from Chris, from an engineering point, Chris, what happens there is that we have a
professional bodies.
We have EXA, okay, which is Engineering Council of South Africa, and we govern by that body basically to tell us that we want the students to have this skill set and whatever it is, knowledge base. But also, we get audited every 4 years. And there is one statement in there that says that if they come in like this year, and when they come 4 years after this, it must not be the same. That means what we need to do is every year we are allowed to add 5% to that, and that 5% change that we make to it from the time we came in is basically our collaboration with the industry. So they have started an in there to tell us that you are allowed to change this, and that actually comes from when you say who does it, it actually comes from the lecturer itself, and the lecturer is sitting there, and when they have communication. And what happens today is that we hear from industry that they tell us that we're getting students, they don't know how to do this. Okay. And what we then do is we then take that information in, and we that 5%, we then change the curriculum. And we do it ourselves. As lecturers, we do it ourselves. It doesn't come from a very high level. It comes from us at the bottom. But we're not allowed to make huge changes. We make the small incremental changes to it, and just to keep up with technology. Like I told you, we were using microcontrollers, very old microcontrollers. Now we use ARM, and we make those changes. And now with the new challenges of this virus, what we do is we've got the ARM kit that we give the students. Okay, the university gives it to the student. Okay, and we are collaborating with the industry, and because of that, industry gives it to us. When I say industry, I don't mean our industry. I mean the guys who actually make the ARM boards for us. They actually come to us and they have sponsored to us and say that you can have for $10. Everything. So the entire board is $10 given to us. Okay, we in turn give it to the student. All the student needs is a laptop. You can take it home. Don't have to work at the university. The software is all open source. You download the software. One USB cable between the hardware and itself, and he carries on working. And that's how it is. It is as simple as that. And we have went through this exercise and got this working already. So we have this. In a similar manner in schools, if you move from 12, 11, and 10, which are your senior level, and if you've gone quite deep into coding and robotics, whatever it is, give the students the board. Give it to them. They can sit at home when they're on holiday, plug it in, and they can work. It's like they got their own laptops. Most of them got cell phones. This is cheaper than a cell phone. Just plug it in, and they start coding, and they can control things at home. And you give it to them.
Yeah, so instead of buying the next Christmas gift or birthday gift, a Barbie doll or something, buy them a Raspberry Pi kit as a birthday present.
Well, not this one. You don't give them Raspberry Pi.
Okay. Natasha, what do you think about the new curriculum, coding and robotics?
I think it's great. I think it's great. It's basically almost tying up with us, with tertiary institution. It is tying up with us. And what I would like to see is that I think the challenge there is more getting the teachers on board.
Yeah, I think that's where the challenge comes in, and that's where DBE and I think Natasha and them come in as well.
I think I'll be comfortable, and I'm sure Natasha will be comfortable if the teachers were brought on that level, so that you must be confident that the teachers are going to give that. Pass it down.
Pass it down.
If you got that, I think all our problems will.
Chris, knowing and meeting the needs of current students, very cool. Thank you, Chris. Production of these components would be great if done locally. Why not? Yes, it would be great, but there's IPs involved, where huge investment on the electronic side to put up these factories. But yes, great idea.
Custom PC boards, you don't have to go very far. Our country.
Yes, custom PC boards are done locally.
I use them. Like we in Durban here, we got a company called Master Circus, which is not far from us. The quality of the boards are very good, very, very good, and that's all local. It doesn't cost a lot. And also they got a discounting structure where if it's from an educational institution, what happens is that they give it to you very, very cheap. And the electronic engineering on our side, we've got PC board manufacturers. Yeah, they got.
That's part of the course. Or the design.
No, they know how to do it, but if you go to design and into project and you need to have a board made, you can make it. Yeah,
And our new entrepreneurship center will also, we are going to be equipping with all the latest equipment like the PC board manufacturer, stem cell culture. It's a wide range of things that we will be rolling out. Hopefully we have already started with entrepreneurship and innovation, but we don't have a specialized center, put it that way, a building. So this will be a specialized building just for entrepreneurship and innovation. Yeah. And you will notice that the first thing is how do you get your foot in the door? That's the hardest part. So you get a lot of guys coming and pitching ideas to you and things like that as well. So yes, there are pitching sessions. If you have an idea, you can do for a pitching session. A lot of companies, including IBM, Microsoft has pitching days where you can go and present your idea and get some funding. And if anybody likes it, they will fund you. Obviously, they will take some part of your company, but they will fund you. The other way, the easiest way to get into these types of things is to look at a lot of companies are now offering what we call hackathons. Like the Moses Katani Institute has offered two lately, EDTEA. The minister there is, I think, Ravi Pillai. They have offered, started running a hackathon at the moment, right? Where the whole purpose of the hackathon is that they are looking for people who can either work for the organization or develop for them. Okay.
The company that manufactures PC boards, Chris, is called Master Circus.
Type it out here.
Just type it on there.
Master Circus.
And they are in Pine.
You should just give them your email address as well. What's your email? INTIAZH@UT. So if you have any further questions, Chris, or anyone else about master circuits or anything, you can just contact Imtiaz directly or myself.
I use them a lot, Chris. They're very good when it comes to surface mount devices and with regards to very fine pitch components. They're perfect. They actually do it. I design a lot of PC boards which are ARM based. They're all surface mount and they do a great job.
I think we should also tell them, although we lecturers at DUT, we work for DUT, we do a lot of outside work. And as part of DUT, we are allowed to do that, provided that, okay, there are rules in place that they need to know about it, but we are allowed to consult. We do a lot of outside. That's how we keep ourselves updated. We do a lot of courses ourselves, not only teach courses, we also attend courses. We teach courses, we consult to industry, we develop for industry. In certain cases, we take our students with us as part of companies. For example, there's a startup right now, which is couple million rand startup, which I'm involved in, which is called Kiwi Byte, which is with myself and 3 of my students. And we have won a hackathon, and they have now taken us, and they want us to develop for the entire, the product that we are developing is for Microsoft, and it will be sold worldwide. So hopefully within the next few years, I'll be CEO of a multi-million-dollar company. You never know, right? It has happened. The guys at Stellenbosch that did the system for the emergency services.
Yeah.
The guy from Microsoft liked them. Now that I took them to the States and they're developing in Los Angeles. It's now a multi-billion-dollar company in 2 years.
Yeah.
All right. Great stuff. We'll definitely be in touch. Well done, Geneva. Thank you. Chris, that's so exciting. Well done, guys. Such a good model. Thank you. Natasha, looking forward to future workshops with you. Thank you. So from our side, I think that's it. If anybody has any more questions or any other topics that you would like us to go over.
I hope it doesn't stop here. Guys, you can contact us. It's the start of something that should carry on forever.
Yeah, let's build a relationship and let's take it forward.
Yeah.
We have an open door policy. And if you have any event that you'd like us to attend or send us your stuff, if you like our students to attend, send us the information, send us the links. Okay. Our DUT has 33,000 students, so we have access to all of them. So we can send out your invites to all of them. So if you're running a session or a special session or anything of that sort, you can put it out onto our website or onto our LMS or learning management system, and it goes to every student out there. So we can send it out to them. All right. I think, thank you guys. Is there any other questions? Natasha, over to you, or Lockdown, over to you. From our side, thank you so much. It was great.
Thank you.
Doing this was a great experience for us. Lockdown?
Lockdown 7 year. Okay, this is 10 It was a great work. Yes, it was a great workshop. I just wish our geeks or our participants would, get a chance to see your exhibition and what you guys have in store, Hence, I was also asking that, I'm going to contact you after this so that we can discuss what I asked you, in terms of you guys joining us at our booth. We can give you an hour to just demonstrate that and all that.
Yeah, I just forgot to mention, just before pre-COVID, we also ran coding and robotics sessions for school kids, where every Saturday we used to bring them out here, and we call it a fun day. So they play with all the toys that you see out here. They fly a drone, they play with the robot, that type of thing. And we also had a 10-day teacher program. So we taught them Scratch, we call it Python, and to develop a project and how to present or to take it to the school. And the project that we did, we were sponsored by CETA. And every teacher that came for training, that completed a 10-day training with us, were given 3 of these kits. These kits are 3,500 rand each. 1 for themselves and 2 to take back to their school.
Wow.
So we can also contact the CETA. Natasha? Okay, that's it from our side, I think. Chris, you haven't introduced yourself. I see you typed a lot, but you haven't introduced yourself. Just introduce yourself. Who are you?
Ibrahim, can I ask Tabiso to
Okay.
stop recording and then you can just take it off?
Okay, sure,
Yeah.
stop recording. I think the
Sorry?
recording is done by your side.